Hi, everybody. It's David Matsumoto from Humantel. So we've heard a lot in the past year and a half about listening to science. And certainly I think, or I believe that science is important to us today in our society. But when I heard what was said about science, the messages I heard were not so much about the science as it was to listening to those who said to listen to the science. And I thought we were losing a teaching opportunity to educate the public about science. Because the message that has been given during this time is basically that science is something that's beyond everybody's grasp, and people just need to listen to those who kind of get it. Well, I don't think so. So I decided to put my thoughts about science in this brief video as a scientist, but also as an educator. Because what I have to say about science could have, should have been covered through the education of a society. And it's apparent to me, at least, that education, that kind of education has not occurred for many people in this society, and probably a lot of others societies as well. And understanding science to me it's all related to critical thinking, because understanding science is about exercising critical thinking. So let me try to explain my thoughts here in this brief video by starting with what is science? To me, science is an enterprise to generate knowledge. So how does science generate knowledge? I think there's three parts or three layers or levels to the enterprise of science. Probably the most basic level is the individual study. Science involves scientists conducting studies. Now, there are many different types of studies. There are controlled experiments, correlational studies, surveys, case studies, longitudinal studies. We've all heard about the double-blind control study. And on the individual level of studies, science includes what may be considered specialized methods to test ideas that are called hypotheses. But these specialized methods, they're called methodologies. Essentially, there are ways to collect data to test the hypotheses and ways to get a finding that can say that the hypotheses are either right or wrong. And those ways of collecting data, those methodologies, essentially evolve around an idea of reducing uncertainties and any ambiguities that are inherent in any findings based upon those same methodologies. Thus, understanding individual studies requires some degree of just critical thinking about how can you generate findings, right? And again, that's not the purpose of today's thoughts, but basically that's what methodology is. And conducting a single study well requires scientists to employ strict procedures to control as many factors as possible in order to isolate effects and eliminate rival unintended hypotheses from explaining their findings. So research methods, these ways of collecting data, really are exercises in critical thinking with big important labels. But essentially it's critical thinking. Most people can get methodology if it's explained to them as critical thinking in terms of how we can reduce uncertainty and ambiguity in findings based upon a certain way of collecting data. Now, whenever we conduct a study, we do everything we can to reduce that uncertainty or ambiguity in the findings and increase, it's like quality control, right? And increasing the quality of control of an individual study, which is called internal validity, doing so, increasing that quality control, comes at a cost of decreasing applicability to other samples with other methodologies in the real world, which is called external validity. So whenever we exercise more control so that we really know, we reduce the ambiguity about a finding, that is, we increase internal validity, we generally decrease external validity, how well those findings can situate with other samples. And this is just a general characteristic of any individual study. And so there are scientists like me and many other people who conduct studies and generate individual findings. Now, the second level of the enterprise of science, I think, involve studies that study studies, or studies that analyze data from previous studies. So if you can imagine the first level involving many individual studies, this next level takes those individual studies and generates and studies those studies. Oftentimes, this second layer of study involves a statistical analysis of the findings or the statistical findings from the individual studies and puts them all together in a grand kind of analysis. And those things are called meta-analyses. But there are other ways of doing this as well. There are ways of examining a body of evidence, right? Because that's what studies are. They're evidence, they're facts, they're individual facts. And the conglomeration of those individual studies is a body of evidence. And so another way would be to examine the body of evidence just on the basis of logic, just examining the findings and understanding the methodologies by which those findings were generated and drawing some conclusions about them. Now we're drawing conclusions about groups of studies and conglomerations of studies, of bodies of evidence. So that's the second layer of the enterprise of science. And then a third layer of the enterprise of science to me is more conceptual. It's extracting knowledge. It's people, scientists, examining the body of literature that could involve individual studies, as well as the second level studies, studies of studies, and extracting knowledge from those bodies of evidence. And at that point, we can get to some generalizable greater knowledge, right? Because I believe no matter how important an individual study is, it generally cannot tell us about extracted knowledge that's applicable to a lot of people in general. And when we can extract that knowledge from a body or bodies of evidence, from studies or studies from studies, we can generate theories and models, which should then generate more hypotheses that should be tested in more individual studies, which goes back down to the beginning. So the enterprise of science actually is a circle, right? Or is a cycle where theories and knowledge that's extracted at the top produce more hypotheses that feed back to more individual studies at the bottom. And that creates a body of evidence or bodies of evidence that rises up again through studies of studies where scientists extract knowledge, et cetera, et cetera, et cetera. So this process can be referred to in many different ways. And you can take a look at this chart, which may be called a knowledge pyramid. And you can see the bottom of the chart refers to data. And to me, the facts, these individual findings that are created by individual studies, are represented by data at the bottom of this pyramid. That's the lowest rung on the pyramid. It's a bunch of facts. And individual studies, any one individual study can generate many facts, and thus you've got many studies generating many facts. The next level of this knowledge pyramid involves the conglomeration of those facts from studies. So it corresponds to my level 2, studies of studies, which takes those facts on the bottom, even disparate, contradictory facts, and find ways to make sense of them. And this produces some level of information. And then the third level, where scientists then extract knowledge from that information, from those studies of studies, that refers in this pyramid to knowledge. Now, one thing to remember about all of this, I want to mention, is what I call the messiness of science. The findings from individual studies are rarely clean in any one study. And then across studies, there's always contradictory and confusing findings across studies about any one single domain of research. Now, this is especially true when those studies regard humans and human behaviors. Now, I've been studying humans and human behaviors for over 40 years. And I know that how messy it can be in one study, and then especially across studies. It's likely true in all other fields of study, but I'm not an expert in those other areas, and so I won't comment on that. But at least in psychology, with regard to human behavior, there's a lot of messiness in any one study and then across studies. Thus, when people try to convince me about something that, they're wanting to give me a claim about something, I'm not convinced about it by hearing about a study or two that supports that claim, because I'm more interested in hearing about the conglomeration of evidence, that body or bodies of evidence, both pro and con, both for and against that claim. Because on the level of individual studies, I believe all findings from all studies are true, given whatever methodology, given whatever ways of collecting data were used to generate those findings. It's just the way things are. But to believe larger claims, to believe knowledge is what is gleaned from understanding the findings from many studies, both for and against the claim, and understanding the methods or the ways in which those findings were generated. Because that's how we can understand that information. That's how we have knowledge. And the other thing about this is that when people report about studies or studies of studies, anything can be cherry-picked. And thus, for me, it's always one better way to think about a claim or knowledge is understanding all of the studies, all of the findings for and against something, and then making a decision about that, not just hearing one side and not the other. I want to turn to this topic now about wisdom and ask, where is the wisdom in all of this? Because in all of this discussion about science, we're missing what the top of this chart refers to, and a shared understanding of why it all matters and what we should do about it, which we can generally call wisdom. And although studies are of course important, and I've spent a lifetime conducting studies, they are of course important, but it seems like we may need less facts about some things and more shared understanding, and especially wisdom about a lot of those facts in society today, and especially about important topics that are facing us today. And I hope that we can all search for that wisdom and get that wisdom for all of us. Finally, one thing to consider is that science is a method that some or many societies have decided is the primary method of knowledge creation that they will rely on. Nothing wrong with that. I believe in science. I have done science for, as I said, over 40 years, and I will continue to do science. But at the same time, I recognize that it's not the only method to generate knowledge, and especially not the only method to generate wisdom, which is a shared understanding of the knowledge and knowing what to do about it. Knowledge is different than that shared understanding and wisdom. I know a lot of people who have or had a lot of wisdom to impart in my life, who are not scientists, who didn't have advanced academic degrees, who didn't have a job in a university, didn't publish a paper, but they had a lot of wisdom. And I think there's a place for that in society, in addition to the science, not to substitute or replace science or vice versa, but there's a place for that. And we can consider wisdom generated from other sources as well, not just the science, as we consider the advantages and disadvantages of the enterprise of science. Let me close with some words from T.S. Eliot's poem, Choruses from the Rock. And these are 2 lines extracted from that quote. Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? Close quotes. I hope this has been interesting for many of you. It's a topic that I feel passionate about as I proceed with my own attempts at doing science and generating knowledge and not forgetting about wisdom. Thanks, everybody. See you again. Bye-bye.